All right, here's our FRQ question from the second practice test. A study was performed to determine whether or not the name of a course had an effect on student registrations. A statistics course in a large school district was given 4 different names in a course catalog. Each name corresponded to the exact same statistics course. A random sample of student registrations was recorded and the results are given below. All right, course name, statistical applications, 25 registrations, statistical reasoning, 22 registrations, statistical analysis, 30 registrations, and the practice of statistics, 40 registrations, total of 117 registrations sampled. All right, do these data suggest the name of the course has an effect on student registrations? Conduct an appropriate statistical test to support your conclusion. Use alpha equals 0.05. All right, so based on how the data are presented, it's not in a two-way table, so that automatically eliminates the chi-square test for homogeneity and the chi-square test for independence. This is going to be a chi-squared goodness of fit test. All right, so let's start with our first step. Okay, so the name of the procedure, chi-squared goodness of fit test. Significance level is 5%. There are no parameters for the chi-square test, so we don't have to do that part, but we do have to write some hypotheses. Okay, and so the null hypothesis would usually be like the claimed distribution is correct. Okay, but they don't really specify a claim distribution. They just say course has an effect on student registrations. All right. Now the null hypothesis, the word null means no or nothing, so maybe we should just write that there is no effect on student registrations. Right. And what that would mean is that we would expect to have like equal numbers of signups for each of the 4 course names, right? So 25% for each category. Okay. The alternative is what we're trying to find evidence for, which is that there is an effect on student registrations. So we'll say yes, effect on student registrations, right? And that would imply that this 25% for each category is incorrect. Maybe we can phrase it that way. Okay, 25% each category is correct, and then 25% in each category is incorrect. Okay, that looks good there. All right. Let's move on to the next step. Right, so let's check the random condition, the 10% rule, and the large counts. Okay. All right, the random condition, where does it say? Right here, third line, random sample of student registrations. Okay. 10% rule. So we have 117 registrations in the sample. It's a large school district, so I think it's safe to assume that this is less than 10% of all registrations. All right, the large counts, okay? So here we want to make sure that all the expected values are at least 5. Now, if the null hypothesis were correct, right, we would expect 25% of this total number to be in each category. So let's do 117 times 0.25 to get our expected count. All right, that's 29.25. Okay, and this would be the same, right, for all 4 categories. So these are the observed counts here. And then let's just make another column here with expected counts, and each one would be 29, 25. Okay, and that's clearly bigger than 5. Right, now we're going to do some calculations. We'll start with the specific formula. It's the sum of the observed minus expected squared over expected. All right, so let's go ahead and write out some of these terms. That'll be 25 minus 2925 squared over 2925 plus dot dot dot, plus the last term will be 40 minus 2925 squared over 2925. Okay, I'm going to use my calculator to get the contributions here. Okay, so for the chi-squared goodness of fit test, we're going to use the lists. So sorry I can't share my calculator screen with you, but I'll describe what I'm doing. I'm pressing the stat button, and in the edit menu, I'm going to type the observed counts in list 1, 25, 22, 30, and 40. And then in list 2, I'm going to type the expected counts, 29.25, 4 times. All right. All right. From here, we're going to press Stat again, go to the Test submenu, and then go to, it's option D on my calculator, chi-squared GOF test. Okay. It should already say observed L1, expected L2. Degrees of freedom, let's make a note here. The degrees of freedom is the number of categories minus 1. So we have 4 categories, and so that means 3 degrees of freedom. All right, so the contributions are 0.617, 1.797. By the way, this is like the last thing in the calculator output. It'll be labeled CNTRB. 0.0192, and then finally 3.95. Right, the actual test statistic is 6.38, and the p-value is 0.0943. Let's draw a picture as well. Squeeze it in over here. All right, so a chi-square distribution is right skewed. We already labeled the degrees of freedom. 6.38 is our test statistic, and then the right tail represents our p-value, probability of getting something more extreme. Okay. It's low, but it's not that low, right? It's not lower than our significance level. So now we can go ahead and write our conclusion. All right, since 0.0943 is greater than 5%, we fail to reject the null hypothesis. There is not convincing evidence that the name of the course has an effect on registrations. Okay, so no convincing evidence. We didn't reject the null hypothesis.